So thank you for my live audience and those attending virtually. This is the talk, How I Teach Modern C++ One Pixel at a Time, and a quick thank you to the ACCU 2022 for inviting me to speak today. So here's the abstract that hopefully got folks interested in attending this session. And I'm going to be talking again about how I teach C++. And I'll try to give some context to how I'm teaching it, where I'm teaching it, and some of the tools and techniques I've used to create what I think is an engaging C++ course, but you're going to be part of the judge here. So with that said, if I'm successful today, you and I will hopefully have some system for building courses that are effective for our students. Again, your students might vary from the students I teach at a university, whether they're colleagues or professionals. But either way, I want you to have some sort of system that you can use to train and help folks learn C++. And hopefully at the very least of this, you'll have some neat ideas for assignments or exercises that folks can practice to learn C++. And just a note for those folks attending online, please feel free to use the Q&A feature of Zoom. I'll answer those questions at the end so we can have a discussion. There should be time for discussion at the end. For folks who have the pleasure of presenting on-site here in the room, ask questions at any time, and I'll repeat the question for our virtual audience as well. All right, so just a brief, who am I? Again, my primary role and responsibility these days is as an assistant teaching professor, meaning I think a lot about teaching in my day-to-day life, typically C++ courses, computer systems, graphics programming, building game engines, these kind of low-level and systems-y courses that require C++. I also consult as a 3D senior engineer, so I do have my hands in industry and try to bring that in the classroom as much as possible. So again, how I teach modern C++ one pixel at a time, that's the name of today's talk. And again, this talk is focused on how I teach C++ in a semester-long university course. But before we begin, a video I want to show you of teaching. Go ahead and pop this open here. So just go ahead and enjoy this for a moment.
For a number of years now, work has been proceeding in order to bring perfection to the crudely conceived idea of a transmission that would not only supply inverse reactive current for use in unilateral phase detractors, but would also be capable of automatically synchronizing cardinal grammeters. Such an instrument is the turboencapulator. Now, basically, the only new principle involved is that instead of power being generated by the relative motion of conductors and fluxes, it is produced by the modial interaction of magnetoreluctance and capacitive diractance. The original machine had a base plate of prefamulated amulite surmounted by a malleable logarithmic casing in such a way that the two spurving bearings were in a direct line with a panametric fan. The latter consisted simply of 6 hydrocoptic Marsal vanes so fitted to the ambifation lunar wane shaft that side fumbling was effectively prevented. The main winding was of the normal Lotus O delta type placed in panendermic semi-boloid slots of the stator, every 7th conductor being connected by a non-reversible Tremie pipe to the differential girdle spring on the up end of the Grammys. The turboencapulator has now reached a high level of development, and it's being successfully used in the operation of Novertrunnions. Moreover, whenever a fluorescent score motion is required, it may also be employed in conjunction with a drawn reciprocation dingle arm to reduce sinusoidal repleneration. It's not cheap, but I'm sure the government will buy
it. Now, for my folks who are in the live audience today, how many folks understood anything in that? I don't see any hands being raised. How many folks are thinking about leaving the session after seeing that? All right, my live audience is being generous. But the point of that video here, what I'm showing here, and how to relate that to what this talks about, teaching modern C++, is, this should not be your style of teaching, almost anything. Now, of course, that video here is a little bit of a parody, making fun of how we sometimes teach technical topics. But the idea is there's so much jargon there that it's impossible to understand anything. We might be impressed by this scientist or fake scientist, at least temporarily, until we leave the classroom saying, hey, we didn't learn anything here. So, let's set the stage here for our teaching. So again, I have to provide some context for, who my students are in this talk. My students here, and this is a pro tip for you folks to also understand, who are your students, who's learning C++ at whatever level. So my course is a semester-long C++ course, and typically we're working with students in their second year at university. Again, it's a semester long. Sometimes it's only 7 weeks if it's a summer session, so it can be quite compressed as far as how much material gets covered. And typically, students have had at least 2 semesters of programming, so I'm not teaching them from the very scratch of, what's a loop, what's an if statement, these kind of things. They do have some programming experience, usually in Python, Java, or a functional language like Scheme. Students typically haven't seen memory management, so they have no idea what malloc and free is, new or delete. And most of the students coming to take this class are in some sort of data science program where they're wanting to work with big data, go into machine learning, or do game development. So just to make things a little bit more concrete here, here's a little bit of a survey data, and I'll highlight the interesting or important parts that most students are coming in here with a little bit of Java experience. And we can see here we've got about 6 folks who have done C++ prior to this class. And a lot of folks at our institution are using a functional language as their first programming language. And lots of other Python students from the data science side of things. And then I surveyed students during my pre-course survey to see, what libraries had they used or seen. So we have 1 student has seen or heard of or used Boost. 9 students have used the standard template library. Although if I back up here, only 6 say they've used C++ before, so a few have stumbled upon the library here. But not much of other sort of C++ or these types of libraries prior to this course. Then surveyed students to see how comfortable they are with object-oriented programming. So we get a pretty bell-shaped curve here with most students feeling they have an average handle on object-oriented, maybe some students who haven't seen any object-oriented programming at all, and maybe these are our 6 C++ students here. How comfortable are you with C++? Well, the majority here are taking this class for a reason, their first exposure to C++, so not very comfortable here. And what I found interesting about this was I think folks are being pretty honest. So there's a famous anecdote, I don't know the exact number, from a few years ago in which Bjorn Strusup was asked, how comfortable are you with C++? And he said something like maybe a 7 out of 10. So I would say in these types of surveys, folks are being pretty honest with, expressing what their comfort level is in the language, which is a good thing. And that's the point of doing these sort of pre-course surveys, so we know who our audience is. So again, here's my audience, folks who know some programming, but haven't been exposed to C++, memory management, maybe a little bit of object-oriented programming, but again, they're coming to us as beginners. So, this title of this talk is How I Teach Modern C++, 1 pixel at a time, and we'll get into the pixel thing at a time, but I really want you to think about how you're teaching to deliver some value to you. That's hopefully why you're attending this talk, so you can think about how you teach. So a more appropriate title for this talk might be How You Might Teach Modern C++ Next Time. And that way you'll be able to reflect a little bit more on your teaching. Again, whether you're a professor, C++ trainer, YouTuber, manager, maybe you're just giving a tech talk at your current business and want to think about how you're approaching the language. So a little bit of homework for the audience, and this is how I'm going to guide this talk. So whether you're present now, virtual, or in the future, again, I gave you the caveat that I'm a professor, so I have to assign some homework here. So feel free to take notes as you want after the talk, during the talk, or however. But what I try to do is always give myself some structure, some sort of system to follow. So there's 4 things I want to focus on while I'm teaching, just to make sure that I'm in line with my students who I've surveyed here. And the first is figuring out, one, will you commit to a common theme when you're teaching? And we'll talk about why I think that's important. Second, are you willing to sacrifice, say, 20% of your course so that your students have a chance of understanding the other 80% of the material that you have? And again, when we're teaching or training or putting together a talk like this, it can be very tempting to just throw everything you can think of into a course or a lesson and burden your students essentially. This third one, which I'll also talk a bit about, is, do you discuss debugging in your course? And the caveat being early on in the course. And perhaps the most important one here, which is a little bit subtle, is, are you going to teach or talk about C++ without just coming out and saying, hey, this language is really scary. Oh, you also have to know C. What? You don't know that. You're way behind. So, why would we approach teaching by just saying, hey, this is a really hard thing? And I want to caution folks that, again, with our video that we saw earlier, it's tempting to sound impressive when we start a talk, but in fact, that's not doing much for our learners, in my experience. And then, of course, any other notes you have, you should take and steal anything that you find valuable. All right, so with that said, let's begin. So in the first place, why do we even need to think about how we're teaching C++? Isn't this a solved problem, right? C++ has been around 40 years or so. There's lots of textbooks and syllabi and things that we can borrow from. So, when I started thinking about this, why I'm teaching C++, why is there a dedicated semester-long course? Why are there so many C++ trainers out there? Well, one of the great things about the language and why it's used is it's a great language because it can really scale with you as you learn computer science. Whether you're a beginner, I think there's a way to teach C++ as a first course, or later on in the program. I've sort of listed off some things here, just showing how the language scales, because you can start off by learning just procedural programming and doing loops and function calls. And then you can eventually learn object-oriented programming and functional styles, because it's a multi-paradigm language. Then you can start leveraging and thinking about the systems side of C++ with memory allocators and these kind of deep concepts and threading and all sorts of interesting things. Think about software architecture for small and large programs. And even as you learn C++, you can think about the pros and the cons of the actual language design and see how that affects other languages. So there's a lot to really unpack from this language here. And I think that's one of the great strengths of C++ just as a tool we use in industry and as we teach it. So, if we just go to creference.com here, look at all this cool stuff here. There's lots of different links to explore, lots of different things to check out here. But this sort of gets to my next point. What's the greatest weakness for our learner here? Oftentimes what I see is students who sort of look at this and say, wow, I'm overwhelmed. Where do I begin? And again, for a long time, I used to joke and say, at any given time, anybody only knows 20% of the language, which is probably true. But again, my fourth bullet point there, don't introduce or use that joke. You're just going to scare folks. So instead, what I want us to think about is how we introduce the topic and what sort of order we're going to give the topics and tell students what's important. So again, part of a pre-course survey here, I just wanted to ask students, what's their motivation for taking the course? What would they feel sad if they didn't learn it? What are they excited about? Some of these other types of questions. And it was interesting that I got feedback like this, where students said, I don't know enough C++ to know what I'm most excited to learn. The class seemed interesting and I enjoyed the short experience I had with C++ years ago. So again, the learners don't know, so it's really up to us to give them that path forward with the C++ language, us as experienced professionals. So again, bringing back the original question, why do we need to think about how we teach C++? Well, that's our job, right? To provide this sort of map of, hey, there's a bunch of cool stuff you can do, but what's a reasonable chunk that we can guide somebody through in a given duration? What features matter? What's going to be important to the learner's success? So a good course, a seminar, tech talk, etc., whatever or whoever you're teaching, you should provide some sort of roadmap for the students that they can go about. And usually in the form of, at a university, this is a syllabus. But I do find these cool maps here, this one from fluentcpp.com, that presents a lot of topics, but you'd still want to walk students through, from one island to the other to figure out these topics. All right, so let's talk about constructing our course, whatever that's going to look like. Where do we even start? Got this abstract problem of, hey, I'm going to teach students who don't know C++, C++. For me, what I've learned and what's been successful as far as teaching courses is I need a strong mantra or a theme. And again, the idea is anytime I sort of drift away or can't figure out what to do, I can come back to this theme, just kind of repeat it to myself. What's the important thing here? What do I want to emphasize in this course? What's the sort of foundation? Again, if you could sort of draw the course in a picture, what would it look like? And giving yourself these kind of constraints can often be useful just as a designer or trying to get something done. So as you may know, attending this talk, here's my theme for this course: programming in C++, one pixel at a time. I'm gonna give you a little bit of a backstory where this is coming from. Where is this idea of, programming one pixel at a time? Sure, you've got to have something sort of catchy to get students to take the course or get engaged. But, I really had this idea for a long time, thinking about this theme, thinking, well, it could be kind of cool if we did a lot of things with graphics and pixels. And 2D seemed like a reasonable space to live in. And then I also thought about this a little bit more, and I said, well, as the students are learning, I think it'd be really useful if students can see what they're actually programming. They can sort of abstractly do this with input and output and text, but what if they could actually see the graphics programs that they were creating here? And there's really a single article that inspired a lot of this course here, this idea of focusing on pixel-based effects. So here's the article. So this article was released in about 2018 that really captured the idea. And this gentleman here, Fabian Sanglard, has these wonderful articles where he goes back and talks about older games and pixel effects. And he wrote one on the game Doom here of creating this fire effect. And I said, wow, that's pretty cool here. It's something that looks interesting visually. It ends up being a relatively simple effect to create, but I could probably teach it in multiple ways. And students could also be creative with it. You could have the fire rising or maybe swaying back to forth or different colors or make it interactive. And I had all these sort of ideas as I was creating, the first iteration for this fire and saying, this is going to be a great assignment. And I also saw that this was also a very viral effect. Once this article was released, everybody was creating fire. So of course I did my part on Twitter and talked about my thread, my progression of the different types of fire you can create and different ways to optimize it and make it look cool. So, I sort of decided on this long ago, again, around 2018, when this article was created to the first inception of my C++ course a few years ago, that this would be a necessary part of the course, something interesting. And again, what I'm showing here, again, from this article, which you can check out the link later and read it, is, this is the effect here, really, this function here. It's not too complicated. There could be many ways to implement it. And it's small enough that, students could see the core ideas, almost as pseudocode in JavaScript, but have to go through some mental gymnastics and thinking to get this in C++. But there were also many other ideas, even just in this simple effect, using, 1D arrays or maybe 2D arrays. They have to learn about different ways to iterate, make function calls for the different effects they might want to create. And it also just seemed like a more interesting way to talk about arrays. And this idea of having a color palette, which is shown here at the top, where you're essentially looking up the colors. So again, it's just a little bit more interesting or a nice progression after students have learned about what is an array in C++ to store something like color. So at this point, I have a theme for my course, this sort of idea of manipulating pixels. Students are going to write graphical programs so they can see as they learn. And also with these different programs, they're solving real world problems like the Doom fire effect. These are things that were taken directly from games. But it was also important for me to look at this Doom fire effect and say, okay, we're not just going to focus on games here. While that might be the inspiration, I want something that feels a little bit inclusive so that students can be creative, maybe get interested and have their creative touch on the various assignments. So I didn't want to pigeonhole myself into just building games. Remember, I have students from all types of backgrounds and majors taking this course. All right, so let's do just a quick check on our homework here that I gave, myself included, to see, am I following my checklist? Do I have a sort of concrete theme or something guiding? And in this case, I do. I've told you that things are going to be graphical and have interesting pixel effects will be in 2D. So again, that gives me a constraint as to figuring out what types of assignments that I'm going to have. All right, but let's see what the rest of the course is going to look like, because we can't just keep re-implementing that fire effect over and over again, though that might be an interesting experiment to see how far we can carry it. So let's think about what else students are going to build. So, again, at this point, just thinking about what else is going to be inspiring, because I'm not always going to find articles like the previous one. Maybe I could search, some C++ book, some game programming book, and find out the actual from the table of contents, maybe a progression of things that I could teach and kind of retrofit or invent examples that could fit. And again, as long as they fit my mantra or theme, maybe that's okay. But I thought it might be more interesting to just go and have a browse and use some of my other background experience to see what other 2D effects exist out there, beyond the Doomfire, see what else is engaging or inspiring for students. And again, this is an important point whenever I'm designing a course, especially for students, to try to draw from real things so that they can see what they're building. So if you can solve a real problem in your courses, even if it's just a small part of that, I think that can be engaging to students. So immediately I got excited from previous background doing things like edge detection and various image processing algorithms. I said, students can have lots of fun with this, and they can relate to Instagram and Facebook and all the different filters that they're creating. And these are pretty neat and applicable. And if they go to take other courses, they'll have seen this kind of stuff before. And this just seemed like something fun and creative. Again, trying to be very inclusive in what students could build here. And I also like that students, again, since we're doing things graphically, could verify their output. That helps them build confidence. They know if something looks right, they can look at it and just very easily see visually, yeah, we're detecting the edges here of this particular shape. Then I got excited and I said, well, if they're going to start doing all these image processing techniques, then what about procedural textures and noise? Again, something that they can be a little bit creative of, do a little bit of investigation on things like Perl and noise functions, which are shown here. And also just force students to think a little bit algorithmically, because they're not first year students, they're mostly in their second or third years, so they have a little bit of knowledge. They probably want to do something interesting, but they can generate some clouds here or marble or wood effects, and it gives them a little bit of a freedom for what they want to design here. So I said, procedural textures and noise. That sounds interesting too. And then I got really inspired and I started watching talks from the Game Developer Conference. I found this beautiful one by Mark Ferrari. And I'll give folks in the audience just a moment to stare at this here. And if you go ahead and stare at this, you can see that it's animating. You can see a waterfall. You can see that it's becoming day or night and then rising into day here. And then it'll rise back into night again. And what's really fascinating about this image, and I think folks and our audience will appreciate this, is that this isn't an animated picture by any means. This is just one still image. And if you look on the right here, all that we're doing is rotating through some colors in the color palette. And I said, that sounds really interesting. Algorithmically, this is cool. It's a neat effect. Students can show something off to their friends, maybe in almost a sort of viral way. And they really have to think about how to implement this algorithmically and think about how would you build this and how old game programmers were constrained to build these types of systems. So again, I said, we have to have this. This is really cool. And then I started thinking a little bit about different gaming effects, but that they could apply to create whatever scene they wanted. So this idea of parallax scrolling to implement, backgrounds that move a little bit slower than the foreground to give this illusion of depth. And I said, yeah, I've got lots of students interested in games. And if they're not interested in games, then they can create other scenes, maybe from real world photos, and have fun with this. So I said, oh yeah, that's another assignment here. I want them to build this. And then again, I said, this is something cool I've seen. It's very viral, this sort of falling sands game where you have different materials here like water, sand, salt here. You can create plants here, which will grow from the water. And then you can create some oil here and then fire, and then it'll burn different things. And I said, oh, this is going to be a great way for them to sort of think about larger structure and different data types and maybe inheritance. So I saw instantly how I wanted them to start implementing something like this. And I said, falling sands game. Okay, that's another one that's got to go in. This is going to be maybe the capstone project or the big one at the end. So falling sands. And then again, I started getting excited and saying, okay, what about some of these classic assignments that I did in my C++ class that were really boring to me? I had to implement a vector2 class, and then my instructor forced me to, implement operator plus and operator equal and all these different things. I said, yeah, okay, that's interesting, but what if we could do that with lighting effects so they can actually see where's a vector or some sort of data structure being used? And then selfishly, I teach computer graphics, and I just want my students to see some of these things early here. But I thought at the very least, if I'm going to make them go through the trouble of seeing what is available in the language, they should be able to visually see it here with these lighting effects. So another one here from this instructor, Daniel Schiffman here, inspired me to include this. And then I said, okay, that's pretty neat. What about different data structures? How do I get students building things like graphs and graph structures? What would they be able to see? Could I have them plot out a graph or graph layout? That's kind of interesting, but could be complicated to get a right graph layout. So I said, okay, maybe 2D splines. Again, algorithmically interesting. I can talk about various implementations and have students do interesting things with these. So I said, okay, this might be interesting. And I can also see how I could start having students use STL list and vector to create different control points here and generate curves and do something interesting. So I said, okay, splines. Yeah, we'll add that too. And then I started getting really ambitious. I said, okay, what about some more data structures here? Because they're working their way up from splines. What about quad trees? C++ is all about optimization and building cool stuff. So if I have all these little pink rectangles here, and I'm trying to detect if they collide with other pink rectangles, it's not efficient if they detect collision with all these other ones. So, you can spatially partition this scene in some way. And I said, okay, this is again going to be a non-trivial data structure. Maybe students can implement this. And this also got me excited. And I said, okay, I feel like this is a great progression after maybe a binary tree, or they see that binary trees are available and can hear about this thing called a quad tree. And then I kept carrying on and finding more and more and more cool stuff in 2D that I thought might be interesting. I said, okay, we've learned all these things. Maybe they can do a game here with a lighting, and you could have different control points to create the lightning and targets and characters, and maybe scrolling backgrounds and all sorts of interesting things to put things together. And again, a sort of capstone project. So again, this process continued for a while where I just said, I have all these ideas. This is going to be a great course. I'm going to win teacher of the year. Everybody's going to love this and just have a wonderful time. And then they're going to come see me in, computer graphics later on, which I have a passion for. And if they go, do computer vision or whatever else they want to do, they'll have experience of this, and it'll all be, interesting, and they'll be great C++ programmers. So, that's what students are going to build. But wait, not so fast on that last check mark here. Maybe I'm getting a little bit ahead of myself here. So my question I can at least ask my live audience here is, have you ever been part of a class, a technical seminar, where the instructor's going through it and they say, yeah, let's just go through these last slides, really quick, time's running out. Or, I'll let you do the rest of the material after class. Or I'm not going to cover this in class, but, here's some resources, go implement quad trees or whatever on your own. So just gauging for my live audience, has anyone had this experience? Maybe not a computer science class, maybe a math class, but somewhere. Yeah, so I'm getting some head nods. And this kind of breaks all of my rules here on the second bullet point. And, I have to be willing to sacrifice, say, some percent here, 20 could be a made up number here, but of my course so that students have a chance of understanding everything. And if I back up to, these examples, these all look really cool and interesting to me and maybe to some experienced programmers, but can I realistically ask students to implement all of these in a semester? And maybe the answer is yes, maybe it's no, depending on who your students are and where this falls. But I really had to think about this and not get overly ambitious here, because I have to think about my audience. I'm not my audience. I think these are interesting. I'm going to love implementing solutions to these. But my students, are they just going to rush through one assignment to the next and not really learn anything? So each idea here could easily be split into multiple assignments, or I could see a progression within them. Easily take some of these examples like more game-like environments, and we have to be a little bit careful about how much we put into these assignments. So, the other key aspect with this is I want my students to own each of these projects. So it was another thing in this course that I was teaching where I didn't provide any starter code. And sometimes there's reasons to give students a bunch of code and have them implement some features. And I'll touch on that a little bit at the end of why I think that's important, reading my code, for instance, in this case. But the reality is, in order for them to learn and to understand the language, I want them to make some decisions and be able to implement all these projects from scratch, or at least these ones. So about half of these projects have to go here. Now, they can be future assignments later in a game programming course or later iterations of this actual course where we can, borrow or swap in these assignments. And maybe for you or whatever course or exercise you're thinking about, you can borrow one of these that I've found are interesting. All right. So with that said, our course is just a little bit more appropriately scoped at this point. So I give myself the checkbox here. I think I have a shot of students actually learning these topics. And eventually I'm going to show you all the different modules and topics that I taught. But again, we have to remember where students are coming from. There's a little bit of a ramp up with C++. So I have to teach them some of the basics before we even get to the graphic stuff. All right. So again, I have a better idea at this point of what students are going to be building in this course, and that they're just going to build it from scratch. All right, so that's enough that I know what they're going to build, and I sort of have this vision or this roadmap. But what are the students actually going to be learning? So this is something, again, I have to really think carefully about what I want each student to leave from each assignment. Again, I sort of had an idea of maybe where I could implement different algorithms or have them look into the standard template library to implement different features, but I really want to hone in on some specific skills that students will have. And think about how they're going to exercise those skills in reasonable ways, a reasonable progression to present these skills, and sometimes even repeating things. Because again, learning happens in sort of cycles. You have to see things multiple times in different contexts to learn often. So I spent some time thinking about this. And by time, I mean maybe procrastination on Twitter, but inspiration eventually would arrive. And here's what I found, something that initially was very interesting to me. I'll go ahead and read this tweet, which comes directly from the author of this, or Robert O'Callaghan, rather. His article was retweeted by someone else who said, this article is worth reading. And the article is called Print Debugging Should Go Away. And he says it's probably true for most individual programming environments. And then on the other hand, they said, I use printf debugging all the time in different languages, so you still use it. So I started thinking about this. I said, debugging. Okay, I've worked in the real world. That's a pretty important skill. We've all heard various numbers about how much time we actually spend debugging our code versus writing code. So I said, I'm going to do an experiment during the summer semester for my class in which I go to the extreme here, and I'm going to teach students how to print out values in GDB, the GNU debugger, before I even teach them output with standard out or standard cout here. And then I'm just going to report back the findings. So they're going to learn how to use the debugger, not just guess or write ad hoc printf, statements or cout or whatever. And again, I have to give credit where credit's due here. This idea I'm taking directly from Kate Gregory's CPP 2015 talk called Stop Teaching C here. And within that talk, she mentioned at some point that if you want students to see a value, teach them how to do it in GDB. And that rang again, very true to me. And to be honest, when I thought about this a little bit more, I said, well, during my undergraduate and maybe even my graduate experience, I don't remember a single lecture that was just dedicated to debugging, at least in my undergrad experience. So I said, okay, I've got to do this. I've got to make debugging ingrained into this course and really think about that. So here was Kate Gregory's talk, Stop Teaching C. I'll give the caveat, she's not advocating against the C language. She's saying when you're teaching a C++ course, and I'll revisit that again. So nothing wrong with the C language, but I'm teaching C++ here. So I want to focus on best practices here. And of course, here's her antidote saying, use the debugger. So again, that's what I do in the real world. When I'm programming, I'm in the debugger all the time. And that's my tool to get myself out of trouble. And since that's my tool, I need to teach that to my students because, well, it'll teach them the critical real world skill that I say that I'm always learning and using in the real world. And well, they're going to come visit me in my office hours. And, if I'm teaching them these skills one at a time, that's not very efficient. So at scale, I need to teach them how to get out of trouble. Okay. So here were my findings, a little bit of a spoiler alert for my course before I show you exactly what I was teaching. Here's the findings here. So every time I gave a lecture, I taught at least one debugging skill, usually at the end of GDB, and it often be relevant to wherever we were in the course. So if we're just starting the course, it was printing out values. If we were learning about pointers, I was showing them what a segmentation fault is and how to find it. If we're learning about functions, how to get the call stack. If we're learning about threads, what thread you're on, et cetera, et cetera. So that was the idea and what I committed myself to. And the reality is here on this bullet point, most students just figured out cout on week one and use that anyway. So, you can't stop them. And I admit I use printf debugging or cout statements as well. Not always, but, here's the idea though, were my efforts wasted by committing to this debugging here skill? So, no, because students did use GDB or LLDB, maybe not as often as some should, right? They liked resorting to cout so they could run where their program was and see if they're here versus, here number 2 on the next line or wherever. But they at least knew GDB. And since they knew it and it wasn't this foreign or, magical tool that the instructor was just using in office hours, I could still help them in office hours and give them some tips. And often they learned that way when I was walking through them why something wasn't working or just showing them something neat. And often their questions about GDB allowed me to dive further into debugging, which I found insightful for myself. And the other sort of proof of, was this a waste of time? And this is often the hard time about being an instructor at any level, is that sometimes you don't get the immediate thank you, but often I do hear from students who work a C++ job, 6 to 8 months later, whether it's their first internship or whatever, thanking me for teaching GDB. That's how I know I've really succeeded, when they got themselves out of trouble when it really counted. Because I want them to make mistakes in the course, that's fine. It's when they go in the real world that I want them to be prepared. All right. So what skills are students learning? The number one skill, or where I started from, was debugging. And this is where I wanted them to start. So in theory, they were learning GDB or LLDB or whatever their local tool was, and just getting exposure to it again and again and in different contexts. So some fully embraced it, some didn't, and that's fine. As the projects get larger, I think they'll embrace debugging more though. So another constraint with a semester-long course, how big can the projects be? To really use or rely on debugging. That was a constraint. All right, so I got to give myself a checkbox here, discussing debugging, because I think it's an invaluable skill for folks to learn in any context. And I want folks to really think about this next time they're giving a tech talk, maybe on some concept, is how do you get yourself out of trouble? Can you show an example where you got yourself in trouble and how you fixed it? Okay, so beyond just discussing it, actually practice it in front of a live audience. All right, so the next skills that I want students to be building. The standard template library. Why? Well, the next slide here. Well, the way, again, I want to approach C++ and teaching the language is that it's a batteries included language. Again, looking back to CPP reference, we saw all these different links that folks could click on that were interesting. And again, students are coming from languages like Java and Python and so on. So they're used to having built-in data structures, at least in the case of Python, right? Lists and dictionaries, or using Java libraries and so on. So C++ shouldn't be any different. We should teach it or approach it with, yes, you have a set of tools that you can use to build higher level constructs. So I've often seen, and even the first time I taught a C++ course many years ago, I thought, yeah, building a vector from scratch is a good exercise, and building a linked list is a first exercise, and so on and so on. And again, that might be appropriate, but you've got to figure out where you are in the actual program here. A few years in, use some containers so they can do interesting stuff. You can always go back here. So other parts of the standard template library, the algorithms library, really embracing that C++ can be a really beautiful language, especially with the ranges example, right? I think everyone in the audience can look at this example and say, hey, I've got a vector with some data here, and I call sort on it, and it sorts everything. And that's really beautiful to me, that you can do this in 2 lines here. And again, it's starting to show students who have different programming backgrounds that C++ doesn't have to be this difficult language where you're building things from scratch. You have these higher level algorithms libraries that you can use here. And again, I think that's just so beautiful. And it also gave me an advantage as a teacher to just quickly show examples in class without having to write a loop or implement a sorting algorithm, sort of show all these foundations here. So I really tried to embrace what was given to me in the standard template library. And oftentimes, another secret or technique that I was using is just to show them in Godbolt or the compiler explorer tool. Just show them very quickly, open it up, do a little bit of live coding and say, hey, this is how you sort things. And then you can say, okay, maybe we want to print things out. And instead of writing a loop, maybe I show them this different way. And it gets them to start to explore, just again, slowly sinking in these ideas of, yeah, there's these interesting things here, like for each. And then there's a Lambda function. Oh, what's a Lambda? Oh, I've seen that before in Scheme, some of my students. And some who hadn't, it gives them an opportunity to ask a question here. So I think, giving students this sort of sandbox, this environment, encouraging to play was also very important. And the STL was a big part of that in my course. All right, so really embracing tools that are given so you don't have to build everything from scratch. It makes it more interesting, some of the problems that students can solve more quickly. And then encouraging students to play and prototype. If they ask a question, I open up Compiler Explorer and godbolt.org and just check out what the code's actually doing. Write a quick prototype.
Just a question there. Do you show them the assembly code generated, or is it just meant to run it?
Yeah, so question about Compiler Explorer, and do I show them the assembly of the actual code here? So in this particular class, I go away from the assembly since that could be a little bit scary, at least initially. So for this, it's just a quick, more using it like a tool like REPL, for example, to just quickly paste in some code and it builds for quick experiments. I think using this as a tool, I do use this very frequently in a systems course to show them the assembly, especially when talking about optimizations and these kind of things. So invaluable tool for that. Another question from the audience.
Has it ever gone down while you're trying to train?
Yeah, so has Godbolt or Compiler Explorer ever gone down while trying to train people? Not that I can remember, luckily. In the instance that it's not working, I do pretty much everything otherwise on a terminal. So very, low cost. It's easy to make the fonts big so students can see what's going on. So I always have backup. And usually, actually to start, I'm doing things from a terminal. So just to show for an example, I'll load this up. I'll do tmux, which I found a very invaluable tool. And students will always ask about what tools I'm using, right? And I can write some code here, and then I can show them how I'm, compiling on the right side and so on. So I found that very useful for teaching, these sort of quick tools that I can pop up. Another question from the audience. Yes.
In the case, would you explain directly the work reflection or ways for students to ask questions about it to kind of trick interest in them?
Yeah, so the question was about this lambda function here, and would I show them here? Yeah, so this is a trick to just start getting students a little bit curious, depending on when I'm showing this. The very first week when I'm teaching this class, I'll do a quick run through of this is C++, and I'll show them a for loop, just a regular raw loop. And then I'll start trickling in, but, oh, you can do this, range loops, or write a lambda and do, ranges here for each. Again, just to garner interest. I try to always use the simplest thing first, the thing that's going to avoid the most jargon, the least cognitive load, but then trickle in some things that'll make code more readable. So certainly in this course, I'm preferring readability over performance. But to go to the first question, inevitably students will see the assembly code and they'll say, hey, I wrote this different, or I discovered the -O2 flag or whatever, and code's disappearing. Why does that happen? And that's perfect. That's the environment I want students to be in. And often when doing this sort of live coding with students, that really triggers and opens up the discussion. Where students get to see how I work, what's possible, and just ask questions. That's how I know I'm running a good class, when folks are asking questions. So far today, a few questions. I feel good. All right, so our skills that we're building here, again, just getting students to play, quickly prototype. Again, a lot of them are coming from backgrounds where they've learned Python before. They're used to just instant output and seeing things, but they're really curious about C++. So the next skill that inevitably is important here is compiling and linking, C++ being a compiled language. So in the examples that I'm talking about, and often what I'm doing is bringing up an actual terminal to show them compiling and linking. I don't do anything magic. I don't introduce make or CMake or provide anything like that, not well until the last week that I say that these tools exist. But one of the advantages of using a graphics library or doing graphics assignments is that I'm using a graphics library, this one called the Simple Fast Media Library, is it exposes students to actually linking in some code, trying to understand how to compile it, what different header files you have to bring in, how to look at the documentation here and see that, oh, there's some, class or, user-defined type in this library, so you have to bring in this header. And that really starts getting students to think about compilation. And it even gets students to ask questions like, why do we have to do this? Or why are C++ files and header files, why is there that split? Why do we have to have, the sort of interface and the implementation split out? So, I explain it explicitly, but once students start doing it, they re-ask the question and can sort of see the purpose here. So compiling, I find very important. I do talk about the process, what's going on, a few weeks into the semester, and linking as well. which I think the linker, as I often tell my students, it doesn't get enough respect. Often we'll talk about compilation errors, but what happens when you get an unresolved symbol? So I'll force a few examples showing students unresolved symbols, how those arise, and how to fix things. So eventually they'll get a build script, eventually make, but that's not until weeks and weeks into the semester. So out of a 15-week semester, I start giving them these tools at say week 10 or 11, where they're not typing things out in the terminal. I want them to understand how to get themselves out of trouble. It's only 1 or 2 libraries that they're really linking in here. So, you know, it's reasonable scale for them. Right, so compiling and linking, another essential skill that has to be part of this course. And I can't try to cover it up. Again, from scratch, students are learning. All right, so the next skill is here. And again, with this talk, this is supposed to be about teaching modern C++, 1 pixel at a time. So how do I feel about modern constructs versus old constructs? So, you know, when I took this course or something similar, it was, you know, probably before C++ 11 existed. So I didn't really have to worry about this. I couldn't really reflect on my own experience, but I could look at what other educators were doing and what I was seeing online and just kind of peruse around. And I still see lots of universities teaching old school C++ 98 style, which is fine. You know, there's nothing wrong with it, but I think the modern stuff is what makes the language more approachable, right? I just showed an example where we have ranges. You know, we've had algorithm around for a long time, even with 98, but, you know, the really kind of beautiful stuff, in my opinion, is coming with the modern features. So why not expose this to students? And I think it also makes them stand out when on their resumes, they can put modern C++ that they've been using to show that they're with the times. So I have no problem showing them, you know, C++ 20 algorithms, things like ranges, showing them lambda functions, and was as asked, you know, I'll talk about captures and these kind of things with lambdas as needed or as students sort of scale up. I can teach them new containers like string view and why it might be interesting. You know, we start with a string first and we let that go for many weeks, but eventually, you know, showing them, hey, there's this other thing, string view, and having them just look, how is it different than a string? Why might you want to use it? So they can think about, oh, as the language is progressing, we're getting new mechanisms, and that's part of programming. I'll show them things like standard function and how that might be interesting versus the function pointer syntax. And I'll show them smart pointers so that they can use smart pointers as well. Again, that's something emphasized by many folks and can be useful. But my big but here on modern C++ versus old constructs is I do choose a few old constructs first. And this is where I suppose things could get controversial in the Q&A. But I do, for example, teach raw pointers before smart pointers. Again, I think students have to understand what a pointer is doing. That, you know, pointer holds an address. I think, you know, teaching that so they understand what it is. Showing them the sort of pitfalls, you know, that, you know, dangling pointers, double freeze, these kind of issues that arise with pointers. They need to experience that firsthand. Then over the series of the semester, I can shift their mental model a little bit and say, hey, you know, those problems that you encounter with a pointer, folks thought about this for a while and said, well, we can introduce abstraction. Remember how we learned about classes and how we can encapsulate behavior and these kind of constructs? Well, actually, there is a smart pointer that can handle some of these pitfalls. And then I can kind of shift students' mental model. And this takes time, arguably. It took time for me from just a pointer or something that holds an address to thinking more about ownership in memory. Then they can kind of say, oh, okay, that's, you know, if I think about pointers from an ownership perspective and just holding on to a piece of memory, it makes sense that I can, you know, have this smart pointer. So that's where I sort of stand on showing some of the old stuff first and not just jumping to a, you know, templated smart pointer. Smart pointer has too many levels of abstraction. Again, I want to minimize the sort of cognitive load. You can imagine a student getting a syntax error from a smart pointer and getting pages of template errors, being a little bit messy. And students eventually need to learn raw pointers, to interface with C libraries. So there still is some need here. I do the same thing with raw arrays before teaching things like standard array. Same reason, just adding too much abstraction early on. Students are okay overall understanding 1D and 2D arrays in my experience. It's a little bit less abstraction, the debugger, errors and so on. They can just examine the memory without worrying about the type or how many elements the array has or any of these things. So I still do teach raw arrays before standard array. Now that said, the very first thing that I introduce, I just give them vector. And I approach it as, here's a data structure, you can put data in it as much as you want, and then you're, it'll resize and all these things that you don't have to worry about. So they do start with vector, then they learn about raw arrays, and then eventually standard array. All right, so that's where and then it's fair game for pretty much all the other modern stuff. Question from the audience. Yeah.
So I have questions about the order of teaching.
Mm-hmm.
So I want to put to you the alternative argument and see how you rebut that.
Sure.
So I have heard that it is useful to make sure your students can leave the course at any point, and everything they've done up to that point is still useful and sufficient for them to make progress up to the level they've got. So isn't that an argument doing those the other way around?
Yeah, so to repeat the question, there's a rebuttal saying that it might be useful if students were to leave the course at any point that they had seen perhaps smart pointer first and been exposed to that. Because say if they leave at week 5 or 6 and they go get a job or take another course, they should know about smart pointer. That's a very good rebuttal. I guess I have to think about, and this is tricky. If I guess I would want to test this. And I'm trying to think of what anecdotal evidence I can bring forward. Because most of the time I've done it this way. When I have taught or introduced smart pointers first and students find about raw pointers, I typically see that they just are more comfortable with the raw pointers because it's less scary syntax. That's where they sort of stand. The drop, I guess I can ask or say the drop rate for this class is small enough. The majority of students are getting through, which maybe makes it reasonable. To say if I was going to offer this as a 1 or 2 week workshop or something, I might change approaches, especially if I have higher level programmers. Because the other way I could see this is if I know all of my students are coming in from, say, Java and saying, hey, Java, you never delete your memory. Here's how I do it in C++. This thing called a smart pointer cleans up after itself. I think that would be okay. But I have too many backgrounds, so I stick to the majority progression in this context. Yeah. That is a good rebuttal. And I think a lot of the talks you're going to see from other folks are going to start with smart pointer. Absolutely. And I won't question it if it's working for them. This is what I found. Yeah. All right. So here's sort of where we stand. 5 skills that I think are necessary or that I want to be enforcing: debugging, using the standard template library, playing with their code, understanding, compiling, and linking in the build process, and embracing modern C++, at least by the end of the course. All right, so now that we know what we're going to build, let's see the actual course. Folks have been wondering, what does the actual course look like? Here's the web page. You can look at my website, and it's linked there if you'd like to see. More on other versions coming in fall 2022, but here it is. I'm going to go through a few of the modules, not all of them, because I want to keep your attention. But what is being taught? The actual curriculum and assignments. And for this, maybe this will be useful for folks to think about what's the order of things. Okay, so again, module 1, quick tour to show here's all the awesome things. Here's why C++ is an awesome language that you should be excited about. Okay, what are you going to learn? And this gives students the chance to say, hey, this isn't for me, and maybe I'll, take the other course or something. But overall, I want to show them that, this is something to be excited about. Again, inspired from Kate Gregory's talk. That's why I named this module C++ is not the C language. Okay, it's its brand new thing that I want to teach. The next module, I dive into some standard template library stuff, things like teaching them vector, getting them to work a little bit, and just up to speed, working with some data. So again, I want them to embrace early on that it's a batteries included language. Do students understand everything? Are they confusing, different data structures in these things? Yes, it takes a while, but introducing early that, hey, we have all these tools in the language that we can teach. And again, using GDB at this point to just step through code and see what's going on, right? That's how I'm trying to teach them. A question, yeah.
How long are these modules? Are these like an hour or a couple of hours? Or?
Yeah, so the question is, how long are these modules? An hour and 40 minutes. Yep, so pretty decent length here for our students. Yeah. By module 3, I start talking about functions. So again, folks have seen functions before. They're pretty familiar with it, but I've got to talk about some of the C++ stuff, passing by value, passing by reference, some different things you can play around with parameters. It's a little bit scary word early on, but polymorphism, right? But you can have functions with the same name, different parameter types. And overall, they're building maybe a small math library here. And I'm trying to expose to them, what happens pass by value. I can show them in GDB, things like different memory addresses. I'm teaching pass by reference early before pass by pointer, which would also fall on pass by value, but teaching them by reference, just to give them some ideas of what's going on here with functions in C++. And again, I found doing this in GDB is interesting. For them, so they can actually see things with different memory addresses, or at least I can make this claim that things are different. Then finally, by module 4, I teach them output. Again, they figured it out by now. They've done a Google search, but here's where I actually talk about input, output, reading in data from files and so on. And then they're ready at this point for their first sort of graphics project. And for this one, I should have covered up this thing here so you can see if you can recognize this guy on the right side. But their first real graphics project they're doing is a transformation from some image data to an ASCII image here. Okay, so they're thinking about how to work with data, a vector of color values and printing them out here. Right, then we get into thinking about memory. I'm trying to teach the language as, hey, C++ is a language where you can think about how memory is laid out, okay, and how we sort of organize things here. So this is where you get into the raw arrays and pointers and talking about a few of these things. And I'll bring to attention, again, the GDB exercises being shown here. How do I handle a segmentation fault? Again, trying to show students how do they get out of trouble. Module 6, again, continuing on memory. We need, plenty of exposure here, but students are, again, learning about stack and where these copies of things are being stored, heap memory, so they can dynamically allocate memory, static 2D arrays, structs, and so on. And again, we're doing GDB exercises where we can examine memory so they can see what exactly is in an array, that the addresses of the heap and the stack are spread out, so implying that they are different. And then I get into some object-oriented programming, talking about, again, continuing a discussion about structs, RAII here, which I break one of my rules, which I'm going to show you in a moment here. But just talking about how it's nice to clean up your memory and resources when you're done with them, and they can sort of understand that. And then I can talk a little bit about GDB, observing call stacks with constructors and destructors automatically being called. Then we get into some more object-oriented programming, this idea of separating out our files now into interfaces and implementation. I try to come up with some fun ways to explain copy constructors or the three amigos or three musketeers, so they sort of remember, the rule of three. Four musketeers for copy assignment here. Shallow and deep copy, again, re-emphasizing these things. And to the question earlier, even an hour and 40 minutes, might not be enough to explain some of these things, but and maybe I'm jumping a little bit ahead, but a lot of this also is live coding examples here. So I can show the shallow versus the deep copy and say, what happened here? Why didn't these things copy? Okay. All right, and at this point, once they've been doing some object-oriented programming, they know about header files, we are loading in our graphics library, SFML, and they're starting to do some image processing. They understand how to walk through an array here. They're doing some filtering functions, grayscale images, black and white images. This is a blur function. It's a little bit subtle, but just some basic image processing. And then I ask them to implement their own image effect, whether that is edge detect, or whatever filter they want to do. And then the next few modules, we again start focusing on object-oriented programming, getting into more interesting things here. Again, the fire effect starts to appear and we have some structure in our program. The falling sands game, this is the sort of starter code I give, this is what I live code in the class here, building this sort of implementation. And then they have to implement at least 2 or 3 other materials, depending on the difficulty of the materials in this falling sands game. And so they're starting to build some structure in their projects. All right, then we continue on. At this point, so module 14 is where I start, I say getting smart, building some revisiting pointers again, so we can clean up our memory. Students are starting to learn about graphs later on. So the spline project comes up here. And eventually the quad trees, which come in our next sort of modules here. Folks work on the color cycling problem here, so they can think about loading data, manipulating an interesting sort of data structure to implement this, and so on. And then we've got revisiting some topics again. So image processing here. So they're thinking about concurrency, threading, talking about a little bit deeper topics here, getting into the memory model about how threading starts to work. More iterators and algorithms. So maybe they can revisit this image processing example, doing some more interesting stuff, and then move semantics to make things a little bit fast. All right, and then we start wrapping up the course, getting into what I call sort of the auxiliary topics, things that'll be interesting to prepare them for later. So I start bringing in other libraries. So PyBind 11 is an interesting one, so they can start scripting or add a scripting language to interface with their C++ projects that they've already implemented. Building graphical user interfaces. Module 27 usually is at my discretion. At this point, I start talking about other build systems, ranging from CMake to other tools like static analyses, other tools like the sanitizers, just other things that'll help them in their professional experience. And then eventually we wrap up the course here. So here's a subset of what students end up with. Some of these assignments re-implemented multiple times in different ways, and some other assignments not shown, which are more, there are a few text-based ones just as they're getting started, implementing things like a guessing game, Caesar ciphers, and some of these things as they're learning the language. All right, so the summary so far. In this talk, I've tried to capture my process of course creation, providing some sort of foundation for just how I build a class. Can be a little bit messy, but you want to find some sort of structure when you're building a course, something you can fall back on. So this is part of my process here. And I've tried to be focused on the concrete examples that my learners are actually going to develop, right? Showing some of these example assignments here. But there is something missing here that I haven't talked about, which is perhaps the key ingredient, at least that I believe in teaching here. So as we're sort of nearing the end here, the key ingredient is maintaining that excitement and enthusiasm for your students here. Okay, so what do I mean by this? Excitement, of course. And, during my pre-course survey, one of the questions I ask is, what else should I know about my students? Please let me know if you need any additional accommodations, these kind of things. But the majority of the feedback came back like this: excited to learn more from you. I'm excited to learn. I'm very excited. I'm excited. So, that's the sort of, definitely looking forward to this class. So these students come in very excited to learn, whether it's a semester long class, whether it's a, whatever talk that you're giving, right? How do we maintain that excitement? I find that truly important. So some teaching wisdom here. So you can hear it from other folks from me. This one's by Professor Feynman, the late Richard Feynman. He says, the goal of teaching should be not to help the students learn how to memorize and spit out information under academic pressure. The purpose of teaching is to inspire and desire for learning in them and make them able to think, understand, and question. Right. And I think, again, that goes to that engagement, right? To see the lambda and say, what is this? Why should I use it? Why is it better than a function? Right. And sort of expose this and say, yeah, that's a great question. Thanks for asking. Let's, dive into this. Right. So I try to capture that as much as I can. If you want to see this wisdom, from a computer scientist, Morgan McGuire, who was a graphics professor and in industry and graphics, he says, the first responsibility of a teacher is to unconditionally convince the student that they can succeed. Teachers are mentors and cheerleaders first and repositories of knowledge second. That holds at any level and subject for academics and athletics with every student. Again, I find that to be true. My job is to be excited and to, guide the students as they learn and spread my enthusiasm for, whatever I'm teaching. So I think Morgan captures it well here. So, for me, you can't fake the passion and enthusiasm when teaching, though. What if I'm teaching this course and I don't want to or whatever? But, that's why for teaching this, I picked examples I was excited about, things I had experience about. And that often gets students excited, too. And they say, wow, I didn't know I liked C++, or I didn't know I could or was considering a career in graphics or games. So, having honest enthusiasm helps keep your students excited. So, maybe if you're watching this talk, you say, Mike, I don't care about graphics, but I care about whatever other domain there is. And you have that sort of concrete theme. As long as you're picking something you're excited about, that often translates very well to students. All right, so my job and your job is going to be to teach C++ in a fun and encouraging ways. So students want to further self-study, other C++ courses and come to your other lectures and talks. All right, so just a few teaching notes here as we wrap up, and then we'll go to the Q&A. Again, strategies for teaching, you have to identify your audience first. Is it an undergraduate, another professor, some professional programmer, someone who's never programmed, and sort of understand that. The second thing I found valuable, again, this is very applicable perhaps in a university setting, is explain things as if a 10-year-old could understand, or as a 5-year-old is sort of the understanding. And I don't mean breaking things down so simply, but I try not to use any acronyms. I try to write them out always. Occasionally I break this rule, but I show them resource acquisition is initialization. I show them this full sentence probably 20 times before I try to abbreviate it. It's just less cognitive load on the student. I think we can appreciate it when we see, too many 3 or 4 letter acronyms. And then it's just as you introduce and reintroduce a topic, you can progressively dive deeper. If you're using any analogies, remember that this stuff is often new to your students, again, at whatever level. So try to think globally if you're using any analogies or metaphors. I've been guilty of trying to use an American football reference before, and it's just gonna go, over, most of the world's head. So unless you're prepared to explain the game first, use examples that folks will understand, right? maybe, universal stuff. Be inclusive, right? And secondly, tell a story, the parts that'll make folks care, or maybe just something that's interesting. So when I talk about this course being about pixels, I also say, pixel is not a little square, pixel is not a little square, pixel not a little square. And then I give them a little bit of history here. And then they kind of feel like, oh, I'm in the know here. I'm special. I know, everybody says a pixel is a little square, but I read, famous Alva Ray Smith's little article, and he talks about being a point where you sample from, and so give students the inside story, the interesting anecdotes that keep them excited about various things. Tell them about your stories and the battles that you had to implement something, and why it was interesting and what the cool effect was. I think that's very important. And I think also coming with this, identify your own knowledge gaps if you can. And this becomes a little bit harder as we become experts, but being able to say, or be honest with yourself and say, wow, it really took me a long time to understand pointers and try to figure out what made it complicated. What was the thing that made it click for you, and see if you can break that down for your students. I know as I was building these projects, what I was often doing was saying, hey, I had trouble at this part of the Falling Sands game. Maybe I should write a note or a little section to students about what I was thinking about here, or what the trade-off is. Give them a little bit of that guide. Often it'll help the students. Again, this is called an expert bias, and it becomes difficult as we learn more to express that, but something to be aware of. Now, another strategy I have, and I wonder if anybody's caught on to this, is, and this one I'm not going to take any hands or anything, but does anybody hate how many words I have on my slides? I'm breaking every PowerPoint rule here about how much text to have on a slide. Now I get to be upfront about my students with this, but I wasn't so upfront with you folks here, so I apologize for that. But I stand by breaking my rules here. Because what I found, and it's got to be student-centered, is that students like reviewing the slides. They don't like seeing the slide deck with bullet points because they say, well, what was the professor saying there? So I try to guide and tell the story through the slides. Caveat, you have to have thoughtful transitions, right? So that's why there's always these, 1 out of 2, 1 out of whatever, for each little bolded note. That takes a lot of time to do, but it's worth it if you're gonna, make this design like I do, I guess. Something to be aware of. And apologies to my audience here if you've been trying to read everything. You're saying, oh no, Mike, why did you tell me no? So some other notes on just the delivery here. I do live coding for these type of courses about 40% of the time in my class. And again, I think that's important for the engagement. It's probably important even for this presentation. Again, to watch me talk for this long has been too long, right? This is probably the cutoff, an hour of talking, or an hour and 17 as I've got on my watch. My personal university experience, this was very rare. It's risky to do live coding in front of an audience, right? But that's okay. You should make some mistakes in front of the audience and then say, I'll just pop open GDB, right? They should see you fixing these errors. Then they learn, then they gain confidence, okay? I think this is a good thing. Now, often I do video record my lectures so they can see how I fix things as well. But again, the important bullet here is it gives the students to ask, what if we change this, right? What if we didn't do this with a lambda? What if we didn't put the ampersand somewhere? And I think that's important. All right, so just a couple more, ground rules. Students want to know that you're competent, you're the expert, and usually that comes with bullet point 2. Just try to be organized. Your students want you to feel supported. Again, students, that's at every level, right? So I'm going to support my audience here by giving you the slides. Okay, you can review some stuff. I've also found, from our start, students are not impressed by technical jargon. Every once in a while, somebody will raise their hand and say, on week 1 or 2, what about dynamic dispatch? How is that supported? And you have to kind of slow them down and say, well, what exactly is that, or defer that to later, but break things down. And students, again, my level students probably shouldn't be given the language standard, right? I think it is okay to point them to the core guidelines at some point, because you're going to have your students who just want more, and eventually giving them somewhere in a point where there's a definitive answer from an expert, it is comforting to them. But I would say don't start designing your course from that text. Think about doing it from the software that students are going to write. Okay, just my recommendations here. All right, so what's next? The next iteration of this course, fall 2022. Lots of supplemental YouTube videos for these topics. Again, students want to see what's going on. The key word is that they're supplemental, though. They can't be required. Remember our rule of sort of dumping in, too much stuff in the course, especially in sort of our Zoom era of teaching, where students have been inundated by videos. That can actually be detrimental. So a little bit careful, but lots of other resources for those who are in need, right? Enough so students feel supported, but not required. Rotating in some of those new assignments, I do want to try some experiments with some assignments that didn't make the cut. And next time I get a longer semester versus, a compressed summer semester. Things I want more in the next iteration. Again, thinking carefully about this, but reading more code. And this is, the recommendations I get when I talk with you folks at these sort of conferences is students need to be able to read more code because that's going to be a part of their job. So maybe that's my curated samples, maybe some good open source projects. I think there could be a learning experience from that. Question?
Oh yeah, I comment on that. I was interviewing people fresh from college for hire, and I found that it's very traditional to do a lot of implement a linked list and so on, right? Mm-hmm. You don't typically do that in professional coding. So what is important to have professional, right, is to read code. And so I gave the interview candidates various code that was badly written to have them go through and point out things that they would do different. And I realized that none of the people from college had any grasp of what I was asking. They were not used to reading code and thinking critical about code at all. And an experienced coder understand right away what you're asking, but someone from college has no idea what the concept of criticizing code is. Yeah, I guess it's not really taught usually in college.
Yeah, so I'll reiterate that the comment which reaffirms that this is definitely going in the next iteration more, that someone from the audience expressed that they give interviews where students have to read code, and often they have not had that experience in being able to compare and say, why is this bad code? I 100% agree. Because I know when I'm on the job as well, 90% of the time I'm changing code and very little writing a project from scratch where I own everything. So absolutely. Yeah, another question.
I'm now wondering if computer science needs the same distinction language has between English language and English literature. Mm-hmm. Maybe there should be a course on programming and a course on studying other people's code and go and write an essay on the Linux kernel or things like that.
Yeah. Love that idea. So comment was about, should there be a distinguishment like with English or any language where you have an English course and English literature where you have to study something like, say, the Linux kernel and maybe understand some of the design decisions or why the code was written as it was. I think that would be, I'm 100% for that. Often those kind of things, I'll trickle into a software engineering course, which, would be a higher level course. But that's probably a great talk for maybe next year, what goes into an actual software engineering course, because that tends to be a very varied course. Here, at least we're constrained with learning C++, but as we know, software engineering involves many components. I'd love to throw in things like a reorg, in the middle of a semester where you shift all the teams or, things that happen in reality. But having more reading of code, more code reviews, code walks, the things that students would have to do is great. And I'm glad that's part of the interview process as well, because I think it gives a good sense of what students know. So that's certainly coming next year. Something to think about, because I realize not everybody, again, is coming in this audience as somebody wanting to teach a university course, but how to just compress this into a 1 or 2 day workshop. I'm actively thinking about this and how to prepare it, but I would invite anybody to take one of these topics here and just think about how a small game could maybe be taught as a driving example, or maybe one of these effects here, because again, grounding yourself in a concrete idea, maybe something visual, I think can be at the least engaging or satisfying to your audience. So again, just something to think about. All right, so with that, our sort of final check. How did we do on my checklist here, my homework? And maybe there's more things in your checklist, but the one thing I want to emphasize here is, did I tell my students C++ was scary or hard anywhere? And I did a Control F search here in this presentation, and I did not. So I think that's another important thing. Students will read on forums or say, hey, I heard this course was hard, or C++ is scary, or these kind of things. But again, it's just something that's new, right? And things that are new can be more difficult, but that doesn't mean it's scary or unlearnable. So something to emphasize in teaching. So the post-class survey, and yes, some of these examples are cherry-picked by the students, but students were happy here. Loved the course, loved the assignment, loved at least the effort or the appreciation that went into thinking about something would be fun. So I recommend, doing the pre-course survey with anything that you're teaching, seeing how things are going, and then doing a post-class survey. If nothing else, it's at least satisfying to see when things work, but you often get really nice feedback. This was from a non-CS person saying they had a great time and they ended up not hating C++. But highlight this one that they loved, the image-based assignments, and it made it more fun. So there was lots of feedback like that.